In this question, we're asked to show what happens in a J-tube in two separate examples. In one case, we have an open tube, and in one case, we have a closed tube. And these are different, because in this case, this surface of Mercury is experiencing 1 atmosphere of pressure, and this surface of Mercury is experiencing 1 atmosphere of pressure. In the closed tube example, this surface of Mercury is experiencing 1 atmosphere of pressure, while this surface of Mercury is experiencing a vacuum, or no gas pressure. So let's show what happens to the tubes. In this case, we have 1 atmosphere of pressure on this surface, and because it's an open tube, we have 1 atmosphere of pressure on this surface. Therefore, by gravity, these two things will simply level off. So the mercury level inside of the bulb and inside of the J-tube part are exactly the same. In this case, it's a little bit different. Let's start by showing them leveled off. So I just slid this over so that they're leveled off. Now this surface of Mercury is experiencing 1 atmosphere of pressure, which will push this Mercury up because there's no gas pressing down on this Mercury. You learned in class that 1 atmosphere of pressure is 760 millimeters of mercury. But what you have to remember is this scale is in meters. So it's not going to push it up by 760 millimeters, instead 0.76 meters, which should bring us to about 2.26, between 2 and 2.5. So if we go over to 5, that's not enough. It's not above 2 yet. If we go over to choice 6, you can see it's between 2 and 2.5, which is the correct amount for it to go up. So this height difference between the mercury here and the mercury here is 760 millimeters, or 1 atmosphere.